Welcome back. In this video, we are going to solve problem 4-30 that is taken from chapter number 4, Axial Load, and book name is Mechanics of Material by RC Hibbeler, 9th edition. So statement is the weight of kentledge exert an axial force of 1500 kilonewton on 300 diameter high strength concrete bore pile if distribution of resisting skin fraction developed from the interaction between soil and the surface of pile is approximated as shown. Determine the resistance bearing force F for equilibrium. Take P naught is equal to 180 kilonewton per meter. Also find the corresponding elastic shortening of pile. Neglect the weight of pile. So you can see this is kentledge and its weight exerts a vertical axial load of 1500 kilonewton, and this is the bore pile, clear, and having diameter 300 millimeter. So due to the interaction with the soil and with this bore pipe, there is a uniformly increasing load of magnitude P naught, which is given as 180 kilonewton per meter, and there is a resistance bearing force F is applied here on this bore pipe. So you have to determine this F resisting bearing force for equilibrium condition, and then due to the loading we have to find the elastic shortening of pile. So let's start with the solution. So what will be the first step? The first step is that we will find internal loadings and we will find this F for the equilibrium condition. Now you can see this P which is acting downward. So this P is equal to 1500 kilonewton, and there is a uniformly increasing load. You can see the magnitude is increasing from the base and maximum at the top. So at this top we have P naught is 180 kilonewton per meter. So let me write it here. This P naught is 180 kilonewton per meter. So in order to convert into a point load, so this load will be equal to 1 over 2 because it is rectangular. So to convert this triangular load into point load, so it will be 1 over 2 into 180 multiplied by 12. So I will calculate it. 180 multiplied by 12 divided by 2 will give you 1080. So 1080 kilonewton, and there is a bearing force, resistance bearing force F. So these three forces are applied. So we will find this F by using equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So first force which is downward is minus 1500 kilonewton load. So minus 15 plus this load which is 1080, that is upward, plus this F which is also upward, their sum must be equal to 0. So 1500 minus 1500 plus 1080 will give you 420 minus 420 kilonewton. So minus 420 plus F is equal to 0. So it means that F is equal to 420 kilonewton. So this resistance bearing force of 420 kilonewton is required for the equilibrium condition, and which is the answer of our first part. And in second part you have to determine the elastic shortening. So what we will do is that you can see that this load is varying along the length y. So what we will do is that we will section this at a distance of y, and we will find this internal force as a function of y. So I will take this section and we will draw the free body diagram over here. So you can see that this was your uniformly increasing load or triangular load, clear. Here the magnitude is not known, so we will call it P of y, which is not known. Okay, so at the base you have this resisting force bearing force, which is how much? Which is 420 kilonewton. This is F. So when you cut it, you will be having a normal force which is represented as capital Py. Why? Because due to varying this distance of y from the base, the internal normal force will also change. Clear? That will be different at this point, and this point. So first step is that we will find this py. So here you can see the magnitude is 180 at this point, and here the magnitude is p of y, small p of y. So what we will do is that we will take this triangle and this triangle, which are similar triangle, clear, and we will find the ratio of their sides. So 180 divided by this 12-meter length is equal to this small py divided by this distance y. So here we will get this small p of y will be equal to y divided by 12 multiplied by 180. So 180 divided by 12 will give you 15. Okay, so that will be 15y. So small p of y is equal to 15y. So here I can write it as 15y. Now when you convert this triangular load into a point load, so it will be like this. It will be like this, and its magnitude will be equal to 1 over 2, 15 times this length is where we have cut this is y, clear. So it will be 15 y multiplied by y. Okay, now we'll apply equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So P of y, which is normal force acting at a distance of y, that is downward, so it will be minus, plus this force which is 1 over 2 times 15y multiplied by y is upward, plus this 420 kilonewton load, which is F. Their sum must be equal to 0. Okay. Now, if we are interested to find out this normal force at a distance of y, so this P of y will be equal to 15y square over 2 plus 420. And this 15 divided by y will give you 7.5 y square plus 420. So it means that this internal normal force that is developed when cut at a section of y is 7.5 y square plus 420. So if you put the value of y at any length of y from 0 to 12, so you can find the internal normal force that is developed in this bore pipe. Now this is the normal force, so we will move towards shortening of the pile. So for shortening of pile, you can see this load is compressive load. So this loads cause compression in this pile, so the length will decrease. So how we'll find this? So we know that this change in length is equal to P normal force in the pipe multiplied by this differential length over area into E. And if you want to integrate it from 0 to L, so you can find the total length, change in length. So from 0 to L is 12 meter, and P of y is 7.5 y square plus 420 kilonewton. So we will the unit will be kilonewton, so we will convert into newton. So 10 raised to power 3 dy divided by area is pi by 4. Diameter is given as 300 millimeter, so 0.3 square into E. E of concrete is 29 ksi. So 29 into 10 raised to power 3 ksi, or 29 into 10 raised to power 9. Let me check it. 29. So we have to go to the end of the book, and you can check the average mechanical property in KS in unit US customary. Oh, sorry, meter, because meter is in ASI. Okay. So you can see that here, let me show you, this is concrete and high strength. So its modulus of elasticity is 29 gigapascal. So I can write gigapascal is 10 raised to power 9 Pascal. Okay. So that is why 29 into 10 raised to power 9. Okay. So this change in length is equal to integral from 0 to 12 meter 7.5 y square plus 420 into 10 raised to power 3 times dy divided by this area will give you 0.0225 times pi multiplied by 29 into 10 raised to power 9. Okay, what we will do is that we will multiply this term 0 to 12 and we will take out 7.5 y square into 10 raised to power 3 divided by this 0.0225 times pi multiplied by 29 into 10 raised to power 9 plus 420 into 10 raised to power 3 divided by 0.0225 pi multiplied by 29 into 10 raised to power 9 multiplied by this dy. That will give you change in length. Now this change in length, this term 7.5 into 10 raised to power 3 y square divided by this will give us 3.6587 into 10 raised to power minus 6 y square plus this term will give us 0.2049 into 10 raised to power minus 3 and we will multiply it with dy. So this change in length will be equal to integral from 0 to 12 meter 3.6587 into 10 raised to power minus 6 y square into dy plus integral from 0 to 12 0.2049 into 10 raised to power minus 3 dy. Okay, so if you take this 3.6587 into 10 raised to power minus 6 out of integral, so we will left with integral from 0 to 12 y square into dy plus 0.2049 into 10 raised to power minus 3 and integral from 0 to 12 dy. So this will be equal to 3.6587 into 10 raised to power minus 6 y cube over 3 and limit will be 0 to 12. Thus this will give you 0.2049 into 10 raised to power minus 3. We will get integral of dy is y and limit from 0 to 12. Okay, so just put the value 3.6587 into 10 raised to power minus 6 divided by 3 and instead of this 12 cube minus 0 cube plus 0.2049 into 10 raised to power minus 3 and limit will be from 12 minus 0. Okay, that will give you change in length. So when you solve this, now you can solve this, it will give you 4.566 into 10 raised to power minus 3 meter. And in term of millimeter, it will be 4.566 millimeter, or if you round off it, so it will be 4.57 millimeter. So this will be the shortening of length in this bore pipe due to the weight of this kentledge. And that was all about this problem 4-30. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. And if you have any question, you can ask me in comment section. Also, it's a request to comment on my videos and give me your precious feedback about my videos. I will be grateful to you for this kind of act. Thank you.